Earlier this week, a student asked me about this question. You are pushing on an object with a force of 5.9 newtons at an angle of 180 degrees. Your friend pushes on the same object with a force of 8.9 newtons at an angle of 270 degrees. So here's a free body diagram. The question is, what's the net force? We're going to want to know the magnitude and direction of the net force. Net force is asking you to find the resultant vector. And in this case, as in all cases, a resultant vector is found by adding vectors from head to tail, head to tail. In other words, match up the arrow and non-arrow ends of your two vectors. So here I have a 5.9 and an 8.9, 180 degrees and 270 degrees meet at a right angle. The resultant will go from the base of the first vector to the head of the second vector. In other words, it goes from your starting point to your finish point. The resultant force, magnitude, would be the Pythagorean theorem to solve this right triangle for the hypotenuse. 8.9 squared plus 5.9 squared, all under a radical. I'll leave that for you to calculate. Now, what is the angle? When we measure the direction of a vector, we always measure from the foot. First thing I want to do is I want to find this angle here. That angle theta is the inverse tangent of the opposite over the adjacent, among other things. I could have used an inverse sine, inverse cosine. Now that is not the direction measured from standard position. What you have here is a vector like this, measured from 0 degrees. That actual vector would be 180 degrees plus whatever you solve for theta. This would be the answer that you want to leave as your final answer, and here's the magnitude of that vector. I hope this helps in solving problems like this, finding net force.